And we want to say we're going to have a very interesting technical paper today, and we are advised to be attentive so as to get the best of it. But before we continue with today's technical paper presentation, we'd like to announce to us the untimely, or because we'll call it untimely because nobody wants his or our loved one to die. We want to announce to every one of us in the house, our distinguished engineers, that the engineering family has lost an icon yesterday. He is our own engineering luminary. He was the patriarch of engineering in Nigeria. And speaking of no other person, but engineer IK Inua, FNSC, FANG, He passed on yesterday afternoon, and according to the Islamic rites, he has been laid to Mother Earth yesterday. We would like to use the opportunity to pay our last respect to him, even though we couldn't do that yesterday at his burial. With the permission of the chairman, Engineer Dauda Musa, MNSC, FNSC, I want us to observe 1 minute silence in the honor of our patron of the engineering profession in Nigeria. Shall we take 1 minute silence from now, please? May the soul of our engineering patriarch, Engineer Khalil Inua, FNSC, FANG, rest in perfect peace. On this note, permit me to introduce to us our presenter for today on the topic HVAC systems for the control of the spread of coronavirus in residential, workplaces, and health facilities. You will all agree with me that this topic is very apt. I mean, there's no any other time we could have, brought this paper other than now. And our presenter for today, who is going to be doing justice to this topic, is no other but our own engineer, Ibrahim Taju Mayaki, MNSC, Ashray, who is also the partner for Mike Dog and Associate Nigeria Limited. Our presenter, you are welcome to this technical paper session of the Nigeria Society of Engineers Buhari branch. You are welcome.
Thank you, Engineer Alimat Adediran. Thank you, NSC Buhari branch. Well, I don't know what made me qualified for this lecture. I don't know what my technical secretary saw, but I hope at the end of the day, I'll be able to do justice to what he has given me to do. Because a lot of people have said so many things in recent times. There has been a lot of webinar online discussing COVID, the aftermath of COVID, and all whatnot. But this is just my little understanding of what an HVAC should do in this situation. So I'll be sharing my slide with you guys. Well, the topic is HVAC, systems for control of the spread of coronavirus, that's COVID-19, in residential workplaces and health facilities. We all know what HVAC stands for. For those of us that are not familiar with that letters, H means heating. The V means ventilation. And the AC, we all know what AC means, air conditioning system for the control of coronavirus. Well, in time memorial, humans have been finding it difficult to regulate comfort in a space. Most times in HVAC, when you regulate comfort, you're actually dealing with the indoor air. Now, we are talking of the temperature of the air, we are talking of the quality of the air, we are talking of the humidity of the air in that space where we sit in our offices, in our homes, or in health institutions. So there are certain criteria that determines what happens in our spaces. We normally have airborne contaminants, and these are material that are mixed with the air. They find a way of getting into our bodies, and in as much as they do that, the body becomes unhealthy. For airborne are germs that float through the air, and after a person might have spoken, coughed, or sneezes. Those are the mediums of movement of airborne contaminants. For droplets, which is particularly what we are dealing with now, because by scientists and the medical practitioners, they've made us to realize that the COVID, the coronavirus that we are all talking about today, is a droplet. And this droplet can be transmitted through coughing or sneezing from a sick person to somebody that is not sick. And this could get into you through your mouth, through your nose, or through your ear. And that's why part of the protocol from the World Health Organization is that if your hands are not properly cleaned or sanitized, do not touch your nose, your mouth, or your ears. I mean, your eyes. Yeah, we have gases too that could be a source of concern to us, particularly our respiratory system, because these gases can be transferred through our bloodstream, and the body will continue to carry the germs, the virus, the bacteria all over and start transmitting. The contaminant can be responsible for a variety of ailments, such as what we are dealing with now, respiratory problem. Mode of transmission of COVID-19. There are two main transmissions for now. The third one is still being examined or debated by the medical or scientists. Now, the first one is the large droplet, which emits when we sneeze or when we cough, particularly people that have been infected with COVID-19. Another source of a contact is by hand or hand on surfaces. And that's why part of the protocol also says we should desist from handshaking. Then we should also desist from placing our hands on objects that we are not too familiar with, particularly when you go out to supermarkets, pharmacies, and some other places, public places. It is highly advised that you should not place your hand on the counters or on the tables, because these are mode of transmissions of COVID-19. Just like I was saying, the third transmission route that is gaining more attention from the scientific community is the facial oral route, which means if an infected person passes excreta, there is a likelihood of coronavirus to be in it. So recently, somebody shared a message with me on WhatsApp that I should try as much as possible to disinfect my sanitary line from the WC, floor drain, wash basins, kitchen sinks, using hypo or G or any of these bleaching agents. I didn't actually take it for granted. I did that because I'm not too sure of what will happen. So it's actually a time that we all are at unease for now. Then this is a diagram which shows the mode of transmission of COVID-19. You can see an infected person sneezing or coughing. Then you see the droplet moving airborne. You can see the diagram which explains in itself how this thing can be transmitted and contracted. So we all need to be very careful wherever we go. Let's be sure of what we are touching. And as soon as we are leaving any public places, let's ensure that we wash our hands through the running water. If we don't have a running water, then we could do it alcohol-based hand sanitizer. Now, the objective of this discussion is that while the world is firmly in grip of COVID-19 pandemic, this paper tagged how HVAC can be used to reduce the level of transmission. Unless precautions are taken, COVID or any pathogen could be distributed through a building by HVAC system. More particularly, where you have a central air conditioning system, where you have a network of ductwork, this could be a source of transmission, because we all know that in air ducts, air moves, and in as much as air moves, any of these droplets that find its way into that air part will be carried along, recycled, and be dropped back into that environment. So the likelihood of contracting it is very high. So we should be very careful. Indoor air quality and energy consumption. One of the most important challenges today is how we improve and maintain indoor air quality in buildings, while at the same time, we need to be mindful of the overall effect of energy consumption. Because when you talk of indoor air quality, particularly we are talking of air conditioning, we are talking of ventilation. So if systems are not properly designed, if systems are not properly optimized, this could lead to high cost in energy consumption. And we all know what energy bill says in our country today, particularly where most of us run on self power supplies, diesel, or the small generator that runs on petrol. To address both indoor air quality and energy conservation, ventilation standards, classifications, and mechanical code has evolved. There has been a lot of standards that people have worked with, and from time to time, those standards are being upgraded, they are being reviewed just to meet up with what the reality of the day is. Air cleaning technology have been developed to provide healthy and comfortable indoor environment. Environment could be residential, which is our various homes. Environment could be offices. Environment could be public places, hotels, schools, hospitals, supermarkets, and what have you. So air cleaning for both particulate and gas contaminant can be critical component in indoor air quality. So we all need to be mindful, particularly the designers of HVAC system. We have to put in mind when we are designing what and what are we intending to achieve by our designs. Design guides and considerations, factors that can contribute to indoor air quality problem. Constantly changing interaction of factors. So you have to be sure of the source of the pollution. You have to be careful with your design, just like I've mentioned. You have to be careful too for those facility maintenance that will come after the design and implementation has been carried out, because after we have long gone, projects have been completed, delivered, some people will come behind you to occupy those buildings, to maintain and operate those systems. So you need to factor them into whatever designs that you are making, so that you make life easy for them, for easy maintenance of those equipment. Those are the things that affect the level and type of environment that we create. Yeah, indoor air quality controls involve integrating three main stages. First, you have to manage the source of the pollution, either by removing the pollution completely from your environment or by isolating people from that environment or where you have the pollution. The second is to dilute the pollutant. Dilution means displacement. Assuming we have a droplet of COVID-19 in an environment, they can use air to dilute it. What they mean is that they can use air to flush it out from that environment. So these are methods of controlling our indoor air quality. This can be done through ventilation. The ventilation can be neutral ventilation or natural ventilation, or it could be mechanical ventilation, as the case may be. Now, the third is filtration. Particularly, just like I said, when you design and you are designing for situations like these, please be sure that filtration is an integral of whatever you are putting for people to use after you have logged on. There are classes of filtration that happens. We'll look at them as we go on in the lecture. Now, functional requirement of a good and efficient ventilation system. Now, the rate of supply of fresh air into the building has to be known. Air movement or air change per hour has to be right. Temperature of the air has to be right. Humidity has to be right. Then the wholesome, that's the purity of the air, has to be right too. These are standards that have been made use of. People have referenced them to a lot of webinar that has been on in this period. We have actually 621, which is for multi-story building and other buildings. We have actually 22 for low-density residential building. Then we have a FGI guideline, which is Facility Guideline Institute. It's an American-based institution that controls working environment and what happens. We have ISO 14644 classification. We have EPA, which is United States Environmental Protection Agency. We have BPI, Building Performance Institute. We have a World Health Organization guideline with respect to indoor air quality of selected pollutants. We have a Building Performance Institute of Europe. We have European standard, which is 15251. We have a Federation of European Heating, Ventilation, and Air Conditioning Associations. ASHRAE standard 170, which is particularly referencing ventilation of healthcare facilities. Now, infection control in residential and commercial buildings. In Nigeria, most residential buildings are not airtight and adequate ventilation are not provided. We all know that what those codes says is that if you have a building, as much as possible, the building must be airtight. So if your building is airtight, the tendencies of getting in pollutants is negligible. Now, your building should be properly ventilated. I doubt how many buildings, particularly residential buildings that has adequate ventilations. Most of us rely on natural ventilations. Our bedrooms sometimes and most times are not ventilated. Kitchens are not ventilated. So those are the issues in this part of the world that we need to start looking at after this pandemic. For commercial building, where central or mini central systems are deployed, it is expected that positive pressure systems are recommended. But we need to be sure that that is actually what we are doing in this part of the world. Nearly all our residential buildings are cooled by wall-mounted, high wall-mounted split unit, free blow, cassette unit, at most, maybe ceiling concealed in some cases. Ventilation. Let's see how we can use ventilation to control infection in our buildings, particularly residential and commercial buildings. Just like I was saying, they said exhaust ventilation system of toilet should always be on 24/7, particularly in this period of coronavirus pandemic. And make sure that under pressure is created. When they say under pressure is that you create pressure, I mean, you create airflow. You make sure that there is air transmission. There's an airflow pattern in your building. Increase hour of operation, which means the ventilation, particularly mechanical ventilation, should start 2 hours ahead of occupation of a space. Residential, commercial, in particular now. We have supermarkets that are just coming back after the lockdown. So one would have expected that before they open for businesses, those trading floor should have been ventilated continuously before people get into those spaces. Even our offices too, we need to have been ventilating them before we start opening up for businesses. So what we are saying is, start the ventilation 2 hours ahead of occupation and let them run at low speed. This is one of the design challenges when you are specifying ventilating fans, particularly mechanical ventilation. Ensure that your fan are variable speed. We have talked about energy consumption. Now, if you have a constant speed fan, it means even if you need to take a pinch of or a very small quantity of air, or you have to ventilate a small portion of your building, particularly in the central ventilation, it means the speed will run at 100%. But if you have a variable speed mechanical ventilation ventilating system, which means you can regulate the speed in relation to the energy consumption. So let us bear in mind that when we are doing ventilation before occupation, let the fan run at low speed. And when we have evacuated the building at the end of close of businesses or close of work, we should ensure that those ventilation systems are still running at low speed. So keep ventilation on 247 with low speed and ventilation rate. In buildings that have been vacated due to the coronavirus, it is recommended that before you open, just like I said, make sure that those buildings are properly ventilated. In demand control ventilation, we all know that when we breathe in and we breathe out CO2. So we should make sure that our set point of CO2 in it, these are not common in this part of the world, to have a CO2 sensor measuring the level of CO2 that are generated in an environment. But in an event that we have it, then our minimum value should not be more than 400 parts per million for a nominal speed operation. In building with mechanical ventilation, it is recommended to actively use operable windows to boost air exchange. That's our windows are openable. Let's open them to create more ventilation. Open windows in toilet with passive tag. For people that live in a multi-story residential building, you know that passive tag is most of the, is commonly used to ventilate the sewer line. So in case you have a passive tag, make sure that all your toilet windows are open so that you will not create a back pressure into your building. Then air conditioning and humidity control of HVAC. Transmission of some virus in building can be limited by changing air temperature or humidity level. There are some viruses or bacteria that will actually not function under certain temperature or humidity. Sorry. But for COVID-19, according to scientists, they said, unfortunately, this is not the case. That for us to be able to regulate this particular virus, our temperature and relative humidity has to be at above 30 degrees centigrade and 80% relative humidity. So it's a challenge that we all need to look at as we go on, because certainly the world will not be the same again after this pandemic. So a lot of things has to change, and a lot of design method has to be improved on, particularly in Nigeria. Some system, fan coil unit, ceiling cassette, ducted type, large central air handlers work with local room circulation. If possible, if the use of air conditioning in that particular environment will not cause any significant discomfort at this point in time, it is that those units should be put off. Fan coil, split unit, etc. have quartz filters. Quartz filters allow microorganisms to pass through them. Quartz filter, what they do is to restrain large objects to pass through. So in this case now, we are dealing with an object that is less than 10%, less than 5 micro whatever that they told us. So in this case, fan coil unit, split unit, and all whatnot that we have in our respective homes and offices would not be ideal. So if this is not going to cause any harm to us. I think at this point in time, or we are not too sure of the environment, particularly commercial buildings. Yeah, maybe residential building, you can still have your air conditioning running because it's you and your family. And in as much as you don't entertain visitors, then you can continue to run your system. But for public places, it is advisable that this should be discontinued. Switch air handling units with recirculation air, that's 100% outside the air. Those air handling units can work. Fan coil unit, either off or operate so that fans are continuously on. Do not change heating, cooling, or possibly humidity set point at this point in time. Now, these are diagrams that try to explain the situations that HVAC system can be used or can be as a source of contaminant into our building. Now, let's look at this fig 2. We have room 1 and room 2. And in those two rooms, we can see terminal and terminal. Those terminal are fan coil unit, window unit, split unit, free blow, ceiling conceal, whatever. Those are the units. Now, if you look at it carefully, what we are saying is that in this particular fig, there is no ventilation system. There is no extraction of air, or there's no supply of fresh air from outside into the two spaces, room 1 and room 2. So the only way that you can get air or ventilation into this space is either by opening window or you open your door. That's when you come in or you are going out. When the doors are open, that is when you get in ventilation. That is when you get in outside air. When we say ventilation, yeah, we're talking of outside air intake into the building. So the only time that this happens in fig 2 is that you open your window to take in outside air, or you open the door, either you are going out or you are coming in. That is when you have it. So for situations like this, it is extremely difficult for the virus to pass from room 1 to room 2 because there's no any how do I put it? There's no any, there is a barrier in between those two rooms. That's why you see the asterisk there. There's no interaction between room 1 and room 2. Now, for fig 3, look at what we have here. We have one AHU serving room 1 and room 2. Now, the AHU does not have ventilation. Ventilation in the sense that if you look at the AHU, there is no any indication that there is an intake of fresh outdoor into the AHU. So what we only have is supply air into room 1 and 2 and extraction of air from room 1 and room 2. In situations like this, ventilation will only happen if you open your window or you open your door. That is when you take in outdoor air. Now, systems like these, if it's not properly filtered, particularly the return air or the extract air back to the unit, back to the AHU, then there is a possibility that we pass the virus either from room 1 to room 2 or room 2 to room 1, depending on where the infected person is. So it is recommended that should we want to go with units like this, absolutely, you need to provide HEPA filter or MERV, which is a medium efficiency reporting value 13 or 14 filter, has to be provided. Now, these two systems, fig 1 and fig 2, can give you different results if we incorporate mechanical ventilation into those systems. Now, Fig 4, we have a ventilation unit. We have extraction. Then we have outdoor intake. Now, look at room 1 and room 2. Of all these rooms that we have been looking at, there's a physical barrier between them. There's a wall demarcating room 1 and room 2. So transmission through that is already taken off. So the only source of transmission here now that we have been talking about is through the circulation of air. Now, for this particular fig, Fig 4, is a combination system, because we have in whole building ventilation, there are 3 systems. We have extraction, we have supply, they have combination of the 2. Now in this system now we have combined system. We have ventilation system that extracting. We also have ventilation system that is supplying outdoor air into the building. So in this situation, there is chances of spreading the virus from room 1 to 2 or from 2 to 1 is reduced completely through the dilution of outdoor air. And we can see that there's no mixture between what is being extracted from those 2 spaces and what is being injected into those spaces. The only possible means of contraction would be if you have 2 people in any of this room. One of them is a carrier and the other one is none. So which means the carrier will infect the non-carrier. So that is Fig 4 for you. For Fig 5, we have AHU, we have supply air ducts, we have extract air ducts, we have outdoor air intake. Now, if you look at this diagram very well, there is just an appliance that have been introduced into this system, and that is the recirculation damper. Now, assuming we have this kind of installation in our commercial building or in our office complexes or school, what we can do in situations like this is that since we have COVID-19 pandemic, for us to spread the virus, all we need to do is to shut down that recirculation damper, which means there will not be extraction. All we need to be doing at that point in time, or what that AHU, air handling unit, will be doing, is to take fresh air from outside and send into the building. So in situations like these, cross-contamination is avoided, virus dilution is achieved. Now, single zone all-air HVAC, this is open space, and this is the most commonest type of system that we see in our commercial spaces, supermarket, cinemas, or theaters. This is what you see, because it's a large open space where people walk in to pick items. So in these situations, if the recirculation damper is presently open, it is advised that that recirculation damper should be shut so that the level of virus transmission can be mitigated. Infection control in health facility with 8 to 8 HVAC system. Now, from basic principle, the action taken in hospitalization of highly infectious people are 3. Segregation, which is what they term as isolation. Anybody that travels, as soon as you are back in the country, they say, go and do a self-isolation, which means you are segregating yourself from the society for a period of 14 days as recommended by WHO. Now, you can also use air lock to segregate people. You all know what air lock is, creating two different pressure, negative or positive, depending on what you are intending to achieve. Now, the second one is for us to reduce the level of concentration by diluting that virus with high air change rate, especially for intensive care units. Then we should be able to take away the contaminant from our environment. And that's why the NCDC has been saying anybody that has been recently coughing, sneezing, malaria, and some other symptoms should call them for test. So which means they are trying to take away the source of contaminant, which are infected people in our society, because we have been told that this virus is at the top stage, which is community spread. So what they are trying to do is to take away the source of contaminant. The contaminant here are the infected people in the society. So they are trying to take them away. So those are the three ways of controlling infection in the healthcare system. But we'll look at them in detail. Now, infection control protocol. Just like I was saying, we said spaces the pressurization, which means we are creating a negative pressure in that environment. To transform existing, because from my little understanding and research, I've discovered that a lot of our healthcare facilities do not obey these principles. Most of the hospitals that you go, they don't have isolation centers. Most of the hospitals, even the operating theater, which is to operate at a positive pressure system, you most time find ceiling cassettes at most, wall-mounted unit. In a very rare situation, maybe National Hospital, I know they used to have a dedicated HVAC system for the operating theater. I don't know if those systems are still working, but I know at the installation period, they had a mini central ducted system for each of those operating theaters. So either they are working now or not, I don't know. So, but what we are saying is to transform, because for me, I believe building health facilities now, we all know that one, most of construction activity has been affected by the pandemic. Sites have been closed. So for us to say we want to start building health facilities now, I don't think it's possible. What people are doing is makeshift canopies, tents are being created as infection centers. So if that is what we are doing, we are like retrofitting to accommodate what we have or the challenges that we are facing. So in this situation, then we need to make sure that we increase extraction from all those spaces that we have created as our isolation centers. We are taking away air from that environment. Make sure that the air is being taken away at 15%. That's 115% of the supply air. When you do that, you are creating a negative pressure, which means air from the environment will move into that space. Rather than air from that space moving into the environment, that is what negative pressure is all about. You are trying to take air from the environment into the space and displace it. If you create a positive pressure in situations like this, it means the chances of the virus escaping from those isolation centers into the environment is very high, because the drift of the air is from inside to outside. Now, introduce a new exhaust fan if they don't have for circulation of the air. And what they are saying is that recommended should be equal or greater than 12 air change per hour. Then maintain continuous negative air pressure not less than 2.5 Pascal or 0.01 inch water gauge. Now look at this diagram of isolation room. If you look at the blue color, you see what they wrote there is exhaust air, which means in the isolation center, for you to create a negative pressure, you have to extract 15% above what is being supplied into that environment. And if you look at the arrow on the door to the isolation center, you can see the arrows are showing towards the arrow indicates that the air is moving towards the isolation center, which means we are taking air from the corridor from outside into the isolation center to be dispelled out. Then if you look at the other side, on your left hand side, where you have supply air, this is a negative pressure. And this is a positive pressure because you have offices. And in offices, you do positive pressure, which means you are putting in more air than what is being extracted. You are doing positive pressure. So you can see that the arrow on the door of the corridor to the offices is turning towards outside, which means you are making sure that whatever contaminant that you have within that spaces are being dispelled out of the environment. So those are the difference between positive and negative pressure scenario that you have in an HVAC for control of infection in healthcare or our commercial areas. Now, we talk of air movement, air exhaust management. The expulsion of exhaust air from hospital stays or infection centers or departments must be subject to absolute filtrations. Now, they said absolute. I mentioned earlier that the filtration should go through MERV 13 or 14. Those filters are specifically made to be able to extract to the last of the virus. We are talking of 99%, 99 point something percent of filtration in situations like this. So if you can use existing system, fine and good. But in a situation whereby you can't use it, then you have to create you have to create a new extraction. And if you are doing that, you have to incorporate HEPA filters and the MERV 13 or 14 filters. Then bear in mind that those filters should be positioned such a way that it is easy for people that will maintain them. And let's bear in mind that whoever that is coming in contact with this filter, because they are highly infectious, must be highly protected. You must wear personal protective equipment for you to be able to do this maintenance. Either these are being done at our isolation centers, I don't know. I know that ASHRI, Nigerian chapter, when we saw some of these isolation centers, the chapter took it upon itself to go around, met with Lagos State government to give our input on what a typical isolation should look like in situations like this, because most of those centers are makeshift. Now, when you exhaust air, when you exhaust air from an isolation environment, make sure that there is a minimum of 10-meter distance between the source of air intake into the infection environment or space and the exhaust, so that you will not do what is called a short cycle, which means you are recirculating whatever you might dispel or you might have expelled from that infectious environment, which means you are recycling the virus back into the space. Now, it is possible to connect easy with control. Control means in case there are limited access to where those filtration equipment are installed, ensure that you have an alarm or something that will give you a warning that this filter is clogged, so that you can go there, remove it, and replace as the case might be. Infection control continue. We are looking at air movement method of controlling infection in healthcare system. If it is necessary to provide new independent auxiliary extraction, I've mentioned this. Most of the hospitals today are not designed ab initio to be infection centers. They are not isolation centers. So if anybody is converting a hospital or health care facility into an isolation center, then you need to look at this in detail. Make sure that you provide extraction where there is none. And if you are providing those extractions, make sure that those extractions are properly filtered. Where applicable, just look at the system and make sure that the system is working fine. Now, create a new air intake duct from the rooms concerned. Those are things I explained. Then make sure that as much as possible, you provide a conducive environment for the patient that will be staying in the isolation center. Make sure that the ducts are designed such a way that the level of noise in those environments are actually controlled. And there are regulations or standards for you to reference in terms of noise level that you can achieve in various applications. Then this diagram shows what happened in an isolation center. If you look to your right, you see a vertical airflow into an isolation center. The air is being dropped from the ceiling level. But you can see that the extraction of the exhaust is at the lower level. Most times, not more than 15 cm from the finished floor. Now, just like I've explained, ab initio is that when you pump air into the building, make sure that whatever you are taking out in an isolation center is 415% of what you have supplied. And if you look at what these two pictures are saying, they are saying that the airflow or the drift of the air or the draft of the air should be towards the bed, which means that is where the infectious person is staying. So we are taking the infection away from the building towards that place, rather than pumping the air and rather than creating a positive a system where the exhaust will be coming towards you, the medical staffs, the frontline health workers, you understand? So this is what this diagram is telling us. As much as possible, ensure that the flow of air is towards the bed in a negative pressure. Then indoor air recirculation. Since the virus can survive in air for several hours, they said on stainless steel about 72 hours, on cardboard about 24 hours, and all whatnot. It is necessary to prevent possible contamination of the air by eliminating air recirculation when it exists and in case of intervention of non-healthcare structure, prohibited due to risk of cross-contamination independently of COVID-19. Local units, such as our split unit, fan coil unit, VRV system for heating and cooling, only recirculate air within a space. That was the fig we saw in fig 2. Those units, they only take back air from the space, recycle it, and throw it back into the building. So if we are not too sure of the occupants of that environment, an office that are being shared by 2 or 3 people, and you have just one split unit working, or one ceiling conceal, one fan coil unit, or what have you, it is advisable that at this point in time, those units should be shut down because there could be recirculation of the virus between that environment. In hospitals, indoor air recirculation is allowed only in the operating theaters because the level of infection in the operating theater is low. So in case of intervention on COVID-19 patient, it is recommended not to modify HVAC system by its sufficient, but if it is sufficient to have post-intervention decontamination period, then you can discuss with the hospital authority and go ahead with your implementation. And HVAC infection control. Now, intensive care units are created in isolation center. We've known that not everybody that goes into isolation center actually requires some level of intensive care unit. There are some which their immunity is a bit strong that can fight the virus. They might not need the respirators and some other appliances. So, but for people that will require such equipment to function or to survive in an intensive care unit, then it is recommended or advised that one, the bed space should be 15 meters square per bed. Equipment should be 60 to 800 watts per bed. Then the lighting should be 5 watts per meter square. Then the space area for people should be 5 watts per meter square. Now, they are saying the minimum outdoor airflow, just like I have said earlier, is that your air change per hour should not be less than 12. In some instances, they will say 15. In some instances, they will say go and use 20, depending on your choice. But you should make sure that whatever you are using is adequate and is good enough to take care of your air recirculation and ventilation. Then the supply air should not be more than 18 degrees centigrade. Relative humidity between 40 to 60 degrees was what was used in Italy in the heat of the pandemic. Now, this is an intensive care unit. You can see that green color shows you an existing air handling unit. But because I said those systems are not designed for this purpose, then at this point in time, those systems are supposed to be down and create units. If you look at the diagram very carefully, you'll see 2 units at the 2 sides. You'll see one with red, which is an extraction. And you can see that the extraction is taking place behind the bed. So this is what is expected of us to do in time of this pandemic. Terminal cleaning, which means droplets, an important fraction of the precipitate find their way onto surfaces and equipment within that environment. So it is advised that those terminal, return air grill, supply air grill, air conditioning units are clean, sanitized from time. So recommended that in this period of time.
Engineer.
Yes.
Yeah, so maybe we have 5 minutes more so that we can take few questions.
Yeah, I'm almost done.
Okay,
so you
thank
can
you.
Sit, at least once in a day and make sure that personal protective equipment are worn when you are doing that. Make sure that vacuum cleaners that will be used in that environment have HEPA microfilters. Use soap in detergent solutions to clean if you have to do so. Absolute replacement of filter. These are the references. ASHRAE standard 921, 922. These are indoor air quality standard. 170 has to do with healthcare facility ventilation. HVAC design for healthcare facility. Thank you for listening to me. I hope I've been able to do the needful that have been given to me to do by my Oga Engineer Mayowa. Thank you.
Thank you, sir. That's Engineer Ibrahim Tajuddin Meyaki. We thank you for your time. He's a partner. He's the partner with Macadog and Associates, one of the leading MEP consulting firms in Nigeria, and one of the oldest too. He is a master's degree holder in engineering management from ABU and a member of Current, NSC, ASHRAE, and Society of Fire Protection Engineers. So we thank you for your time this morning.
Thank you.
Now already afternoon is 12 p.m. now, 12:02. So without wasting so much time, we want to take few questions from participants. If you have a question, can we see your hand? Can you raise your hand so we can know you want to take it, want to ask a question? Okay, Engineer Majid. Please go on. Engineer Majid.
Yeah, good afternoon.
Good afternoon.
Good afternoon.
Yeah, first I would like to thank our presenter for that beautiful presentation. It was indeed an eye-opener. I have like two questions that's combined with contribution. First is on the mode of transmission. Our presenters took us through different types, from foaming, from droplets, from fecal oral. But there's another part that is gaining ground among the scientific community, which is airborne. And if that part is actually neglected, then my question coming now is, how can we, if it's not airborne, if we assume transmission of COVID-19 is airborne, it's not airborne, sorry, how can we use mechanical system, HVAC system, to control? Because we assume the system is, the transmission is not going to be airborne, it's just through droplets. And then from the scientific community say, if it is through droplet only, after a distance of about 1.5 to 2 meters, it drops onto the ground, onto the surfaces, and then it does not become airborne. So this is the first question and observation I want to make, directed to our speaker. Second part is on the control methodology. There's another type of control that we found in healthcare system, which is air disinfection system. We talk of ultraviolet germicidal irradiation systems that are to be installed to inactivate the pathogens. What advice will our speaker give to us on this as well? I think these are then the last one is, I think you mentioned it briefly during the presentation, about when our government started to build the isolation centers, pictures were flying around on social media. I observed that majority of them are designed with split systems. And he mentioned that they have been talking to government. Just like a question on that, were they able to listen, our government, were they able to listen to install maybe extraction system into these isolation centers? Because as split systems are just recirculatory systems. They are not going to extract, they are not going to dilute. And the filters in them are not designed to undo pathogen control. These are just my few observations and questions. Thank you very much.
Thank you, Dr. Majid. Engineer Ibrahim.
Yes, well, with respect to airborne, Now, actually, it's a droplet. But what we are saying is, if you have air moving within a system, the likelihood of those droplets being evacuated by the air is high. So that's why we are looking at regulating the mode of recirculation of air within a space. That is one. Two, Dr. Majid mentioned of UVGI, ultraviolet germicidal light. Yes, they make use of them, but they actually do not take care of complete filtration. They are not, there is a light. It's just like anybody that has been to any water treatment plant, you normally have a UV light that helps to decontaminate that environment or that water that are passing through the treatment. But in addition to that, or even before the UV light, you normally will have filtration units, because filtration is able to take care of, particularly the HEPA filter, they take care of 99.9% of the contaminant within a space. But the light, yes, the light can be can be an addition, can be an add-on, but actually is not a replacement for HEPA filter or MERV 13 or 14 filters. But it's an add-on. It can be added to it, sure. Then I think the last one was, he said, was actually advice taken to? I want to say yes, because we got a letter, that's ASHRAE chapter, at ASHRAE Nigerian chapter got a letter of appreciation from some of the partners that are working with Lagos State government. And I think actually the Lagos State government, particularly the governor, in one of his speech, he made reference to that too. So it's noted.
Okay, thank you very much for the precise and awesome response. I believe Dr. Majid is satisfied with the responses. I believe we've. So, Engineer Aristobulus, please, you have the mic.
Yeah, good evening. I'm sorry, good afternoon.
Good afternoon.
Yeah, I really appreciate what this gentleman has said. But I just want to add a little bit. Yes, I just want to add a little bit, I said. Regarding the UVGIs, those irradiations, yes, they work together with the HVAC system that has been put in place. And the intention here is to make the virus inactive, such that we can have proper ventilation to suck up those airs, like you've correctly said, yeah, given the appropriate design to suck up that infected part of the air, yeah, given the time it elapses. The second comment I want to also make here, in terms of, you see, sometimes approach matters a lot in terms of engaging government parastatals, or getting the government's ear. Sometimes when we come in a little late, it becomes difficult to break in. That means there's a need for some public relationship before this time. Having said that, I think we can, I think some of the challenges, I'm not speaking to the government, but some of the challenges they have at the moment is that most of the isolation centers come in as donations from people like you and I, or some of these big people that give this hospital. For example, I don't know if you heard yesterday in the news that the Catholic group of people, church or Catholic mission, contributed about 400 units of their hospitals across the nation, and that the government should go in there and then take advantage of this as isolation centers. And I like the way the news presenter presented it. He said adaptation, to be adapted for isolation centers. So you see, if we're able to find a way of entering, have a way of entering these ones with an idea, this idea of ensuring that we create that safe enclosure for them. It goes a long way to help in creating a safe environment. So I think there's a need for an early interface with government. We don't wait when the problem is there. Pay them visits. You know, this is who we are. This is what we do. You know, even sometimes drop you so that when we now speak, when an issue comes in, we have a listening ear. I really love what you guys are doing there in Buari. The collaboration with ASHRAE and this NSC approach. I cannot. I think it cannot be overemphasized. Where people come together to work as a team to ensure that that goals that are global that would help everybody, you know, is putting besides the interests that we have, but looking at the good of people and also how best we can help ourselves and the association that we speak about. So I think it's great. It's a great approach. But maybe the only question I may want to ask here is just for clarification. You know, the pressure gave that the pressurization value you gave about 2 point, was it? I want to be sure, is it 2.5? I know the 0.01 inch water gauge is appropriate, but is it 2.5 or 25? So that's just the only area.
2.5.
Okay, all right. And that's one of the standards, right?
Yes.
Okay. Thank you so much. That's just my only contribution. Thank you so much.
Thank you, Engineer Aristobulus Tauna, the Secretary, ASHRAE Nigeria chapter. In the absence of any other question, I will hand over to the chairman to give proper appreciation to the presenter and to all those who have contributed. My chairman.
Thank you very much, my technical secretary. You've been doing a wonderful job. I want to appreciate everybody for listening attentively to this wonderful presentation. Let me also appreciate my vice for standing in for me throughout this meeting. I was in another meeting, I'm just joining in. Actually, I missed part of the meeting, but I think I will make it up. Once again, I'd like to thank the presenter, particularly Engineer Taju Mayaki, who is a member of ASHRAE. He has actually delivered this paper wonderfully well that most members I can see the turnout. We are up to about 25 to 30, to 30 people. I think that is a very good number. And I want to appreciate Engineer Taju for this wonderful opportunity, for your contribution to the Nigerian Society of Engineers. In the appropriate time, we will issue a letter of appreciation to you personally for this effort. Permit me to also thank our collaboration with ASHRAE. In particular, we have received a series of lectures from them. And like I said, we can't thank them enough. We still have so much to benefit from each other. And so I'd like to seize this opportunity that we look forward to more presentations, from members of ASHRAE who have been doing wonderfully well, and also particularly all our members who have been very encouraging to join this platform during this presentation. On behalf of the Nigerian Society of Engineers Buari branch, I'd like to thank my chairman and the vice chairman, Engineer Limat Adediran, for standing in for me, and then the technical secretary who has been the brain behind most of this presentation. I'd like to thank you. My ESCO member who have joined us during this meeting, I thank you very much sincerely. I also thank Engineer Abdraman, who has been a very good floor, Engineer Osman.
Your audio is gone. Your audio is gone for a while.
Okay, so sorry.
We lost you for like the past 45 seconds.
Oh, sorry. So I'm sorry once again. I've appreciated all the members, including the presenter, and particularly the ASHRAE. I've appreciated ASHRAE for partnering with Nigerian Society of Engineers Buhari branch in coordinating most of our meetings. And like I said, there are so many opportunities that we need to benefit from each other. I'd like to thank particularly all the presenters and our technical team for standing in for throughout this meeting. May I also thank Engineer Tauna for his support and always been part of this presentation, and also Engineer Osman Abdurrahman. They have all been very wonderful. I thank you all sincerely. We hope to see you again in our next presentation. I've also thanked members of the Executive Committee of NSC Buhari branch for supporting us on this mode of getting in touch with all our members. I thank you sincerely and hope to see you in our future presentation. Thank you. Stay safe wherever you are and still follow the guidelines of the COVID-19. We pray that God see us through this hard time. Thank you very much. I appreciate it.
Thank you, Chairman.
Thank you very much.
You're welcome.
You are very